They're trying to pack out this cut and fill calculations for your practical workshop. Quite a lot in it, so I'm going to go quite fast, so please rewind, do whatever you need to do some extra reading around it if you need. So we've got our reduced levels and our distance. The first thing we want to do is we want to get an estimation in graphical form. That's what I like to do, just to make sure I've got my calculations correct. So what I've done, every single ordinate, so every single level is an ordinate, a coordinate, whatever you want to think it like. And then my graph, just use Excel for this one, but you can manually draw it out. So there's 10 meters in between each of the ordinates, basically. So the measurements were taken 10-meter intervals. So that is my distance, D. And then I'm looking at my reduced level. So what was the levels that were taken? So I just plug them in. Ordinate 1, ordinate 2, ordinate 3, all the way up to the last one, ordinate N, which is ordinate 9. Okay, so from this I can use the graphical method to calculate the area. So what I've done is everything under 818.5, I'm just assuming this volume, this area under here is this distance, 80 times the height, which is 818.5. That gives me the area underneath this line here. Okay, and then everything above this line is a bit, as you can see, there's lines halfway through, so I've just done some little 10-meter boxes. So if you imagine a distance between 0 and 10 is 10, and then the difference between 818.5 and 819.5 is 1, so 10 times 1 is 10. So each of these boxes represents 10 meter squared. So did I say 10 times 10 or 10 times 1? Oh, anyway, so every box is 10 meters squared. So all I do is I copy them around, and I try to sort of use my head a little bit and visually look and say, well, the top left box, it's got a little corner there, a little rectangle. Well, actually, the two rectangles that we haven't got a box covering, that should cover those two. So that's fine. That's still 10 meters squared. And then the same with the middle sections here. The boxes that are 10 meters squared, any that go over the line, they can sort of, that area here can fill in the bits that are missing under the line. So I've done a bit of a visual representation to work out an estimation, and what I've done then is I've added that on. So I found that I probably fit 60, so 6 boxes, each 10 meters squared. 60 meters squared I can add on top of that line. So I've already calculated the area under the line, and then I just add them together. So this is my estimate now. So that's a graphical estimate, that's the way of doing it. So the next step is to just do the mathematical method using formula. Mid-ordinate method, it's assuming basically what I've done with these boxes. It's taken like, halfway between the 2 points, and then that's all it's doing really, and then it's sort of turning it into a box really. That's mid-ordinate. So the way to do that, again, don't worry too much if you don't understand what I'm saying. Go and look on YouTube, have a little look, get your head around it. But the process is very simple. Ordinate one, as long as you follow the formula, D is the distance, the equal distance. It would say L if it was length, and it will tell you in the formula if you're not sure. But the equal distance between each of these ordinates is 10. So D represents 10. And then ordinate 1 is right there in purple, ordinate 2 is in blue. Okay, so I know what they are. Ordinate 2 again and ordinate 3, I know what they are. So all we're doing is adding ordinate 1 and 2 together and then dividing them to give that average in between the average, in between the two values. And then you go on and you go ordinate 2 and 3, right, what's the average between them? And you go all the way until you hit ordinate N. Sorry, I've gone forward a bit. Ordinate N being the last ordinate, which is the ordinate 9 in this case. You might have 20 ordinates, you might have 5, you might have 1, 2, whatever. It just depends. I don't know how you can make an area out of 1, but hey, that's it really. So you carry on. As you can see, I've put the boxes here so you can visually see what the numbers I'm plugging in are, and I've left gaps for the bits in the middle, which I haven't, just to let you have a go. And then the calculation follows through like this. Okay, so I would do it like this. I'd just keep the equal sign in the same place, get your formula at the top and just follow through your formula really clearly. Write it out like this so it's really clear exactly which calculation you're working on at a time, and then follow through each individual calculation to get you to the end. So as you can see, when we hit the end, my area was calculated at 65,539 meters squared. If I have a look at my estimate, 65,540, oh, I'm really not far off that one. So I'm quite comfortable that that calculation was done correctly. Okay, so that's that with the mid-ordinate method. So then we move on and we say, well, what about the trapezoidal method, which is slightly different? Again, go research what the differences are, where you would apply them, because they are applied in different circumstances. However, if you were asked to use this method, here's the formula. D is again that equal distance, and then ordinate 1, ordinate n being the last one, okay, because you could have any number of ordinates in this reduced level chart here, and then I've represented all the rest in colours for you. That makes it nice and easy. Okay, and you follow it through. Okay, so we get to the end. Oh, lovely. My calculation is very, very similar again, so I'm quite comfortable with this calculation. And then the last one that we're going to look at is the Simpson formula. Now this is more complicated. It's the first and the last, and then it's 4 times the even ones, and then it's 2 times the odd ones, right? So it gets very, very interesting. However, again, you just follow the method, right? So as you can see here with the coloured boxes, all I'm doing is rewriting out the formula, and where it says 01, ordinate 1, I just put in the value, which was 820,765. Please make sure you put the ordinate on, don't put the distance, because the distance is this d value, you know, it's the equal distance between, right? We're trying to get distance times height. Now height is these ordinates, right? But we can't get the exact height because it's such an unlevel plane. So the idea is that there is a bit more complexity to these calculations, but if you just follow the process, you'll find them really easy. Okay, so there's colours for you so you can follow it easily and get yourself to the end. Okay, and there is the final value, 65,539. Again, really not far off, so I'm really happy with that calculation. So then right to the very end, so what we've done is we put the area, we start off putting it in graphical area to get an estimation. We've done that, then we calculate it, and we've calculated it using 3 different methods, right? But there's always ways to check accuracy. Try 2 methods, right? Do a graphical and then a mid-ordinate method, do a mid-ordinate method and trapezoidal method, whatever works to get you to check. You just don't rely just on one calculation that you're exactly right. Make sure you do these checks, they're quite important. Last up, don't forget the fact that we're talking about, in this instance, we're talking about something that's 820 meters above sea level. I'm not going to be digging down 820 meters to get this ground level, right? I'm going to start at 818 or maybe a bit lower. It depends how far your foundation, whatever you're trying to build, or you're digging to, the depth you're digging to. So please be aware of that. So although I've said reduced levels start at 820, you might want to move this bit, you might want to move it so you've got a bit of a baseline. So the areas that you're calculating is not the full height from sea level. Okay, you might be looking at from just 1 meter below the lowest point, or even just the lowest point. So that's easy enough to do. All you'd have to do then is maybe do another table, another column, and your ordinate 1 wouldn't be 820, it would be something more like 2.265, and then you just follow that through and make sure that the same distance is used. If you're going from 818.5, for example, it would be the same for all of them, and that will get you through it. Okay, so I hope that helps. Thanks for your time and good luck with it all.